Hope everyone can hear me now. Thanks so much for having me here. I'm actually based in Madrid, so it's really nice to see DevOps Days coming to Madrid. I'm originally from Lisbon, so I still speak a mixture of Portuguese and Spanish, Portuñol we call it, but we'll stick with English. I think that's better for everyone. So I'm going to talk to you a little bit about Kubernetes and team interactions and what's the relationship between those two. Because I see a lot of talks and really great articles about Kubernetes and great technology and really solving complex problems, but I always kind of surprised because they almost never talk in depth about what are the teams, which teams exist in those organizations, how do they interact, who is doing what are the responsibilities. And I find that those two things are strongly interconnected, right? The success of technology depends very strongly on the people, how you interact, how you offer that technology, and so on. So we're going to cover some of that today. We're going to see, what is Kubernetes really a platform or not? Of course, depends on the definition you have for platform. This idea of this equilibrium between development and operations, and kind of the origin of DevOps, actually. What is team cognitive load and why that matters, and team interactions as well. So as mentioned, I'm the co-author with Matthew Skelton of this book, Team Topologies, which is all about thinking about the teams and the interactions and the behaviors and trying to make that in the benefit of the organization. So many times, I don't know if you have this feeling that in your organization that sometimes you feels like you're kind of fighting the structure, you're kind of fighting the way the teams are set up because it's not really been thought about in terms of how do we help everyone and help the teams deliver faster with better quality and so on. So let's start with the question, is Kubernetes a platform? So in order to answer that, I would first like to talk about an example from Airbnb. So about a year ago, I was at KubeCon London, and I saw this great talk from Melanie Cebula, who is an infrastructure engineer at Airbnb. And she was talking about how they simplified Kubernetes workflow for thousands of engineers. So I wrote this story for InfoQ. I'm also the DevOps lead editor for InfoQ, which is an online publication. And this story got really a lot of page views, a lot of people interested. So just to give you an idea, in about 1 week, there were more than 20,000 views of this story. And kind of on average, for the whole lifetime of a story, it's typically half of that or less. And so I was kind of surprised why this is the story that kind of went viral, if you like. And I think this, of course, it has to do with Airbnb. It's a very well-known, interesting case study, if you like, Kubernetes. But I think was especially the fact that they're talking about implicitly that Kubernetes by itself is kind of too complex, too complicated for many teams to just start using them. And also at this kind of scale, how do you simplify the usage of Kubernetes platform in a way that is effective for all of your different teams, different engineers coming with different backgrounds, etc. So yes, you can look at Kubernetes as a platform. It provides a lot of benefits, like reduce the complexity of running microservices, operating them. It helps with good abstractions for deployments and services and running your applications. That's all good. But there's a lot more that you need to think about, right? You need to think about things like sizing your host, creating clusters, how do I update to a new Kubernetes version, what's the impact on the teams using the platform, how do I do isolation between environments, applications with namespaces or clusters, or how do I do that? And I'm sure if you're a Kubernetes administrator or someone managing that kind of environment, you have a lot more tasks and that you could include here. Perhaps worrying about security is also top of mind. So if we don't have clarity in the organization about who is responsible for all these things that need to happen, and perhaps even more importantly, if we don't have clarity on who is impacted when we're making these changes, when we're making decisions about how we're going to run the platform, then we start have issues, and we start have a lower value of adopting Kubernetes if we're causing more harm than the benefit, right? So it's kind of complicated, right? It's not a straightforward answer if Kubernetes is the right platform. It really depends how you approach it, how you offer it to your internal customers. So let's start by having a common definition of a platform. So in the book, we use this definition from Evan Butcher, which I think is really good, because it talks about digital platform as a foundation, not only of the self-service APIs and tools and services, but also the knowledge and support around them, which should be arranged as a compelling internal product. So when we're talking about knowledge and support and how do we offer this platform to the other teams, essentially we're saying we need to think about having a platform team or a group of teams working on that platform. And we need to understand how those teams interact with the others. So that's why I like to say Kubernetes is not the platform itself, it's the foundation for a good platform, as in the definition of Evan Butcher, right? The goal for the platform should be to make the right thing the easiest thing to do, kind of pave the road for the other teams, so they have less to worry about and they can just benefit from whatever you're using in Kubernetes, the functionality that we know is really awesome. All the things you get from with easier deployments, self-healing, auto-scaling, all the good stuff about Kubernetes. That's why we adopt it, right? But so the hard thing about platforms is that the needs of their customers are always evolving. Both for kind of the old customers, people already using the platform, they're going to start having more specific requests, more specific things that they need to do. And you still need to think about onboarding new customers, either new teams or new engineers, and what's the experience for them. How can we make that easier? How can we think about where this person or this team is coming from and make the platform suitable for them as well? So it's hard, it's always evolving, and we need to keep this at top of our mind. Because what we don't want to do is go into kind of what I call this fragile equilibrium, and the kind of linking back to the origins of DevOps. So DevOps started with DevOps Days in Ghent in Belgium in 2009, and the core idea was to address this problem, this separation between the teams working on development, teams working on operations. So 10 years ago, this was kind of the common way that organizations were set up. And so DevOps Days started, in fact, and the idea of DevOps to think about how can we make it look a bit more like this. How can we get the people from these two groups to actually sit together, talk about the problems that are common to them, and find good solutions, right? So it didn't start with the tools. It started here. And over time, with things like the State of DevOps report and the book Accelerate, that is kind of summarizes and goes deeper into the research around what makes high-performing teams in technology, in software development. And so kind of what we've found is that actually, if we want to go faster, but still with high levels of quality and safety, the ideal is kind of this, having a single team that actually has all these capabilities around development, but also running their services, monitoring, and understanding what's happening in production, right? The same team has this end-to-end ownership. So some people talk about those as product teams, but whatever name you give it, build and run teams, the important thing is that they have this ownership end-to-end, and they're able to take feedback from the live environments, from how the applications are actually running, metrics, feedback from customers, and integrate that as quickly as possible in the next iteration of that software, that application, that service. So if this is kind of the ideal, so in the ideal world, most of our teams would be working like this, but we know that Kubernetes also brings us this advantage if we have it set up correctly as a platform. How does this work? Because Kubernetes is not exactly kind of subtle change, so that's why I call it the elephant coming in the room, right? It's kind of a big thing. So how do we adopt this in a kind of healthy way? Not like this, not just renaming, actually now you're the Kubernetes team instead of the ops team, because now it's cooler to call it like that, but we're still kind of isolated or very little collaboration. That's not the way to go about it, right? So it's important to think about who are the teams managing the platform, developing the platform, and who are the teams who are the customers who use this platform. We need to have more clarity on that kind of distinction. And so it's important to think about team cognitive load, because that helps us kind of balance and understand where are the kind of the borders, the boundaries between these two types of teams. So cognitive load has a specific definition as the total amount of mental effort being used in the working memory from John Sweller. And there are three different types of cognitive load. The first is intrinsic. It means things like, how do I define a class in Java? So if I'm a Java developer, this is something that I need to know to do my work on a day-to-day basis. Extraneous means everything I need to do to get the work done, to get the value, to deliver the value, but it's not directly related to the business or to the problem I'm trying to solve. So how do I deploy this application, for example? This would be an example of extraneous cognitive load. And then germane cognitive load is everything that's specific to the problem I'm trying to solve or whatever product market fit I'm trying to reach. So if I'm working in banking, I probably need to know things like how do bank transfers work and so on. You can kind of generalize it like this. Intrinsic are the skills, extraneous are the mechanics, the things that need to happen to deliver the work, and germane is the focus on the domain, on the business part. So we want to reduce the amount of intrinsic cognitive load, and it's kind of straightforward. We know how to do that through either kind of classical training, but also pair programming, mentoring, peer reviews. All these things help improve, upskill people and teams. The extraneous cognitive load we also want to reduce, and that has a lot to do with platforms. There are other aspects, but platforms are a strong enabler to reduce how much I need to know around deploying, how do I monitor, how do I test, etc. So that we have as much as possible free cognitive capacity for the germane part. If you're interested in this and you want to know more, there's really good articles and talks by Joe Pierce around the idea of hacking your head. So the message I want to get across is that you need to be mindful of when you make choices in the platform, what's the impact on the cognitive load of the teams using that platform. So yesterday on Twitter, someone was talking about, if we automate the creation of cloud environments with something like Terraform or other infrastructure as code, in theory that's great, but if that means now we're going to ask all the development teams to understand Terraform and to kind of manage this new technology and just kind of dump this on their laps, if you like, then that's actually affecting negatively their capacity, because we're saying now that's one more thing you need to know about and understand and manage to be able to do the work you were doing before, right? So we need to think about that when we make decisions. It's not that, it might be a good idea that all the teams now learn Terraform because we expect on the long run, medium long term, there are benefits that make it worthwhile. But it should be a conscious decision to say we're taking a cost now on their cognitive load to learn this thing because it has a value, it's an investment for the future. Or maybe not, maybe we can actually abstract a lot of that stuff into the platform and what they need to know is much smaller than learn Terraform. So Airbnb that I mentioned is an interesting case study. So who has seen this quote, the best part of my day is when I update 10 different YAML files to deploy a one-line code change. That said, no one ever, right? No one wants to do that. And so they realized this at Airbnb, obviously, and they started working on very simple command line-based tools that help the teams not have to worry about so much of this stuff. In fact, what they do is that they have, what you see on the left side is what the development teams need to worry about are specific configurations for their services, for the environments that the specific needs for their environments. And then this tool, kubegenerate, creates all the YAMLs, all the boilerplate code that is needed with sensible configurations and defaults where needed for the different environments. So they have production, canary, and development environments, and then applies it in the clusters. So they're clarifying kind of these service boundaries and providing good abstractions for the development teams to reduce their cognitive load effectively. And so in the book, we talk about different types of teams, and that's related to what are you, a product team, are you a platform team, and so on. So we actually call the product teams stream-aligned teams in the sense they're aligned to some stream of work, maybe a business value stream or regulatory value stream, something that provides value to the organization. And then we talk about other types of teams, enabling, kind of helping upskill and provide knowledge to these stream teams. Complicated subsystem might be needed, but it's kind of an exception. But obviously today we're focusing on the platform teams and how they help the stream teams reduce their cognitive load. So the role of the platform is to provide good abstractions and kind of hide these lower level services that most of the teams need, but they should not have to worry about how do I install it, how do I manage things for deployments, for monitoring, etc. So another very interesting case study I found is from a company called USwitch. So they're based in the UK, they're quite popular there, and what they provide is kind of comparison of home services and easy way to switch, because another one has a better price or it's a better deal, whatever. And over time with their success, they actually moved to kind of comparison of financial services as well. So now they're called RVU. And part of that success is based on the platform ability to help the development team. So they only have about 50 engineers today. And about 2 years ago, Paul Ingalls, who is now their CTO, wrote this great article on Medium around conversions to Kubernetes. I found this really amazing. I've referenced many times because they're really thinking about kind of the intersection between, okay, the technology, what is useful for us, but also which teams do we have, what kind of aspects of the teams we want to maintain, and also looking at data. So in that article, there's this graph which is mapping the low-level calls to AWS services. So to give you a bit of context, in the beginning, all their teams were not 100%, but nearly independent from each other, working on different services, and they were responsible for all the infrastructure. They were given freedom to use whatever AWS accounts they needed, do all the setup of the environments, security, etc. And so over time, as those services grew and those teams got more things to worry about, the number of calls to AWS services was increasing. So the great thing about this, I thought, is that this is actually kind of a proxy metric for cognitive load around infrastructure. The more calls they have, the more they need to be worrying about services from AWS and setting all these things up. And so the goal that they had adopting Kubernetes was not necessarily, yes, was technical on some aspects, but was strongly driven by changing the organization, changing the way that how much the teams had to worry about, and especially with a good platform team. So they wanted to abstract a lot of the things that the development teams had to worry today, so that they could have more time to focus on the business side. So they actually were noticing that over time, these teams seemed to be less able to deliver business value than compared to the beginning of the company. And indeed, after they started this platform based on Kubernetes, then they saw the number of direct calls to AWS going down. Because some teams remain doing the work in the same way as they did before, and other teams moved to the Kubernetes platform for some services. So this is very aligned to what we talk about as the purpose of a platform team, which is to enable these stream-aligned teams or product teams, if you like, to deliver their work as autonomously as possible with self-service capabilities in the platform. And the point is to reduce the extraneous cognitive load. And this is what Paul Ingalls was saying. They wanted to scale the teams and grow as they were doing good business, and they needed more engineers, but they wanted to keep the autonomy of the teams, that they were able to work with minimal coordination and using self-service infrastructure. So not introducing more dependencies on this new platform team, but actually that they could go faster than they were going before with as much autonomy as possible. And for this, we need to first treat the platform as a product, understand that our engineering teams are the customers. Yes, they are internal, but they're still customers. We should think of them in the same way as we think about our kind of external end customers. And treating a platform as a product means it needs to be reliable. We need to trust it, that it's not just going down at any moment without notice. That it's fit for purpose, that we're not building more things than we actually need just because of the fun of it. And it's focused on the experience for the developers. So in the same way that we focus on the user experience for our end clients, we need to focus on the developer experience to make it a smooth experience, easy to adopt. So specifically, a reliable platform, we should be thinking about these types of aspects. How is the support? It needs to have on-call support because this platform is now on the path to production for our services. How do I find out what's the status, the current status of different services? Have a clear definition of how do we want to communicate. How does the platform team would like you to report an incident or ask for feedback or send feedback or ask for help? What are the preferred ways to do that? Is that with Slack, or you can come and see us at the office between this hour and that hour, or what is it? Make it clear so that we're not wasting effort trying to think about that. It's very clear what is the expected interaction. We need response time for incidents because, again, this is critical now for the development teams. If I can't monitor my service, if I can't deploy, then I might be incurring serious costs for the business and the organization. And if there's any downtime, I need to plan, announce, and understand the impact. Or maybe it's just degraded service if we're upgrading to a new Kubernetes version, but understand who is going to be impacted, talk to them, and so on. The way we develop the platform needs to be adequate to the needs, to real needs of the teams, and in this kind of agile way. It's not anymore that we just, okay, give me the requirements and I'm gonna work on this for 3 months and come back to you. No, we expect these platform teams to collaborate with their customers and understand, have this fast feedback, prototype, this kind of agile approach to development of new services. And we want to focus on fewer services of high quality rather than build everything we possibly can in the platform. And we need good product management to do this, to understand priorities, to understand where we're putting the effort right now, and is this the right thing to do. Focusing on developer experience means that we need to speak the same language as the engineering teams, provide the right levels of abstractions. If it's too high level abstraction, then it's not going to make sense for the engineering teams. If it's too low level, it might seem weird, awkward. Why are we talking about this kind of low level services? I should be talking about my services, about my deployments, about my SLOs, etc., whatever it might be. But you need to understand what's the specific reality of your organization because it's going to be different across different organizations. What are the right level of abstractions and services? So one very easy way to understand if we're providing good developer experience, a platform that's fit for purpose, is something that Twilio, which is a company in the US that works on internal communication tools and APIs and so on. And so their platform team, I think every quarter sends out this survey to the engineering teams. And they ask them, how effectively do you feel like the platform helps you build, deploy, and run your services? And how compelling is it? Do you feel like we are listening to your feedback, that we're working on having the best tools possible for what you need to do? And so this is a very easy way to assess, how is the platform meeting this kind of ideas of fitness for purpose, reliability, and focus on developer experience. There are other ways you can think about doing this. You can also look at how's the experience of onboarding new engineers. That can tell you a lot about how the platform is actually easy to adopt for someone who is coming from a different reality. But just thinking about that is important. So for Paul Ingalls and Uswitch, Kubernetes helped them focus on the right abstractions and also operate their infrastructure with minimal coordination. So that was kind of the first step. And then what they did, as in this platform team, was to then look at what are the gaps today in our organization, in our teams, what do they need that it's kind of a cross-functional needs that take on too much effort from engineering teams. So they did, to give you an example, this is from a talk from one of their engineers, Joseph Irving. They did, for example, dynamic database credentials. Most teams were using static credentials. And they did things that help with managing GDPR, for example, extracting data, multi-cluster load balancing. And the third one, which I quite like, which is to make it much easier to have alerts and SLOs for your own services. So this is a screenshot. So essentially, it's an open source tool that they created, where the teams can just configure what is it that they want to measure, the service level indicators, what are the thresholds, and basically that's it, and they get it up and running through the platform. And then they get notifications on Slack when some indicator goes below the threshold, and then when it's back to normal levels. And it's all based on custom resources they created on top of Kubernetes. So custom configurations that their teams can use to do all these things very easily. The other aspect that I found very interesting about their journey was the way they did this, not just kind of the actual services they provided and the benefits, which are there, but also how they did this. So they started only a couple of years ago with only a few services in this platform, infrastructure platform. And they knew that this would be mostly helpful for having a first customer, which was actually one of their engineering teams that was had kind of lower maturity. Perhaps they were more junior engineers. They were not doing any kind of centralized logging. They didn't have really metrics around their service, and I think they were also having issues with scaling their service. So this was a very good fit for the platform team to begin, and already provided a lot of value for that team. And then as they grew, they started clarifying what is the kind of the reliability aspect of the platform. What are the SLAs and SLOs of the platform itself? What is the reliability, latency, etc. So essentially, they were kind of internally promoting the platform. Remember, it was never mandatory. Teams could adopt these platform services whenever they wanted, or not. And so this kind of internal promotion based on data around, how do we serve our platform customers, what is the availability, etc. And they started measuring the traffic that was coming in from the engineering teams into the platform versus the other teams that were using AWS directly, like in the beginning. And this started to go up. They started to see this adoption of the platform. And then at some point, as they created some of those specific tools and services I mentioned for security, for alerts, SLOs as a service, then this was kind of the tipping point. This really made it obvious for all the engineering teams that this provides us a lot of benefit, and it's the right way to go about some of these things rather than doing it ourselves. And kind of their target goal was that they had this team, they told me this, I called here the highest revenue making team. So that was the team that was making more money basically with their service. And they were also kind of the more mature in engineering terms. And at some point they also saw the benefit of, okay, let's use the platform because these are things that we don't really need to worry about. We have a good platform, provides the right abstraction, and we're going to save time to work on making even more money. So this was kind of the win for them, right? But remember critically that platform was never mandated. It was never told to engineering teams, you must use this. It was making it a compelling product, making it the easy way to do things and the fast way to do things without increasing the cognitive load of the engineering teams. So, as I've mentioned before, team interactions are critical to make a successful platform because we can work on great solutions, but if we are not able to communicate the value of these solutions, if we're not able to get people to adopt the platform voluntarily, if we're not able to guide them on their onboarding on the platform and drive it according to their needs, then having great technical services, it might have intrinsic value for us, but it doesn't have a real value. It doesn't make a difference in the organization. So looking at the Airbnb example again, essentially what we're seeing here, even though they don't call themselves platform, they call themselves infrastructure team, they created this platform. And what this is doing is kind of making clear what is the service boundary and making that much smaller than just saying, well, you just use Kubernetes and you go and look at documentation, find out how you do stuff. That's really not a good approach. And so what they did was make the service boundary much clearer, much smaller, and this is what helps them drive down the cognitive load on the development teams for them. And so we need to think about how we make this happen. When we're developing a new service or an evolution of an existing service, we expect there's going to be strong collaboration between the platform team and whatever engineering team or stream team asks for that. And so this kind of collaboration to discover, what do you need, what is the right interface, the right abstraction to provide this to you. Over time, as you get clarity on how this should look like, then the platform team should then focus more on documentation. How do I provide a good support for this service, make it more reliable and stable? And at some point, it turns into this kind of X as a service interaction. We're saying, actually, we don't need to be collaborating all the time. It's this kind of self-service approach, and you just use it. Obviously, you report any problems, you give feedback, but we don't expect that we need to collaborate, the platform team and the engineering team, when we're at the X as a service interaction. And now, this doesn't mean that do we hide everything from the development teams and they don't know anything about Kubernetes. That's not what we mean. Actually, we know what's behind. We know there are the clusters and whatever infrastructure is running. And we should engage with development teams. If there are people there that have interest in this technology and they have suggestions how we can make better use of it or how we can use some new tool that helps us do things more effectively, that there should be this kind of open, transparent communication between the teams. And then over time, you can then grow the platform, right? The platform should start very small, like USwitch did, but then over time, you expect that you're going to add more services. So in the case of Airbnb, they started with kubegen and kubedeploy, and then they realized actually diagnosing problems in services running in Kubernetes is actually not that easy. So I found this image, which is like a flow chart to diagnose a problem in your Kubernetes service. At first I thought it was a joke, and then I found the actual article, and it's not, it's really explaining. And this is not any criticism on the person who wrote the article. I think it's impressive to create this. It's just to highlight this is way too much cognitive load. You cannot expect engineering teams to be effective if they have to go through this. So this is the first half of the flow chart, right? There's another bottom half. So instead, what we need to do is kind of have, if we follow this kind of pattern of, we collaborate for a period of time to discover what the engineering team needs in order to diagnose more quickly, more easily, what information they need, typically from the platform to make their diagnosing easier, etc. Until a point where say, okay, this looks like the right way to have this service in the platform to be usable. And so that's what they did. And they created this K-diagnose service, which basically looks at finds some of the possible problems, picks up all the logs and whatever information might be useful to diagnose problems instead of following that flow chart. And so this kind of pattern works well to evolve the platform according to the needs of the users and not just going and building all this stuff that is really great, but actually we're not sure it's providing value for the engineering teams. So I have a quiz. Who knows what this image represents? Ken, you're not allowed, but anyone else? I'll give you a copy of the book. No one? So this is the cloud-native landscape. So all the different tooling and I guess some frameworks and all different stuff that cloud-native foundation kind of supports or they kind of highlight. This is all the stuff you can use in your Kubernetes ecosystem or part of it. So you see it's grouped by different aspects. It's not so important what's in there. It's just, this is huge. I copied the image from the site and I couldn't put it on Google Slides because it was too big. I had to resize it. And so what I'm trying to say here is it's with a good platform with this type of approach where we actually collaborate with the teams, understand what they need, but we also have the right abstractions that allows to manage and navigate this kind of ecosystem more easily. Why? Because we can think about, either we have a good abstraction and we only need to, we can swap the tooling in the platform underneath without even affecting the engineering teams, without them knowing about it, because it's lower level and we can just, there's this better way to do it, and we try it and then we make it work, and the interface remains the same, or not, or we think there's a lot of benefit from using this new database or what have you, but then we need to work with the engineering teams to understand the impact on them and to get their kind of buy-in that, yes, it's worthwhile learning this new stuff so we can get the benefit. But it allows us to make more explicit decisions about what is the good way to evolve and navigate this kind of huge landscape of available tooling and frameworks, etc. And not just this from cloud native, but other stuff. So USwitch actually has open source all of those tools that I mentioned. This is the one for creating the SLOs as a service in the platform. And so you can leverage that. If that's something that you also need, other people have done it. What you need to understand is your specific context, what your specific platform and abstractions and the way that your teams use it. And so how do I make this work for them? And there are other examples. There are so many examples of really useful stuff. Zalando has this, also does a lot of open source around Kubernetes, like this cluster lifecycle manager and other stuff like that. And so to finalize, because I know we're running a little bit over the time we had, if you want to get started with this kind of team-centric approach to Kubernetes, to platforms, 3 kind of tips that are very easy to start with. Try to start assessing what's the cognitive load today on your engineering teams. How well do you, if you're using Kubernetes already, how well do they understand it, or the platform that you have in place? Are the abstractions at the right level for them, or is it hard and they are frequently having to go and try to read documentation on Kubernetes and try to sort out what's actually happening? So you can do this with simple surveys and talking to the teams. It's nothing necessarily quantitative of how much, how high or how low. It's like, what is the feeling of the teams? Do they feel like they're spending too much time sorting out how to use certain services and Kubernetes in general? Second, define your platform according to that definition of a digital platform, if you like. What's the gap between your current implementation of Kubernetes or anything else? If you look back, this talk could be about any other type of technology, OpenShift or what have you. What's the gap between what you have and that definition of digital platform, of treating platform as a product, providing clear support, help, all those things we've seen. What do you need to do to make that your platform closer to this digital platform? And number 3, start thinking about the team interactions and make them more clear, more straightforward. Who is responsible for that? For what? Is that clear? Who is impacted when we make these changes? Do we know that? And how do we collaborate? Can we start with this kind of pattern of collaboration for discovery and X as a service for kind of stable, reliable services? There's a lot more examples of organizations using this kind of platform approach with very good results. So this is just meant, the slides will be available, I guess, through the conference. I'll put them up as well on my account on SlideShare. So you can look at other examples of companies from Adidas, which is really interesting, to Mercedes and other car companies, etc. There's also an article we wrote on the idea of this talk with some more details if you're interested. And with that, I'm going to end. I want to thank you for attending, for listening. My name and in the name of Matthew Skelton, who co-wrote the book. Thank you very much. I'll be around, so if you have questions, we can discuss.